Wow, we already have over 50 people here. We're actually just doing a mic test, but it's wonderful to see you all here early. We'll be back soon. Hello, and welcome back to our weekly live stream. It's a real pleasure to be able to talk to so many people tonight from all around the world as we spend a little bit of time doing some interesting math. I see that we actually already have 184 people here in today's show. Just as a quick reminder of how these shows work, these are by YouTube policy. They're intended for people who are 13 years of older and parents as well. But of course, the content that's inside could be actually very useful for just about anyone who wants to go and challenge themselves on math. We always organize these shows where the first 15 minutes are to talk about a math problem. And with that math problem, there will be some time for everyone to also think about that. But while you're thinking about the problem, I'll also be helping give some context to maybe parents and or coaches who might be curious about how one thinks about these kinds of questions. After the 15 minutes, where we think about the question and then talk about how to do the question, then I'll say a little bit about some interesting math news that's been going on in the world this week. And then we'll switch into an open Q&A where you can ask just about anything you want, and I'll try to answer all of your questions. Are you ready for some thinking? I have a question that's inspired by the date. Today is 2/22/2020, and our live stream is at 20 o'clock Eastern Standard Time. Now, that's a lot of twos. That made me get kind of curious about this question. Let's think about this. What is the shortest non-empty string of twos that makes a multiple of 7? For example, 222 is a non-empty string of twos, but unfortunately, it's not a multiple of 7. If you want, you're welcome to think about this. I'm not going to tell you the answer right away. Those of you who have watched this stream before know that I'm not just going to tell you how to do it. You got to think a little bit. But that's also how you learn how to do math. And during the time while you're thinking, don't worry, I'll be giving you some hints along the way. And also, I'll be using this time while you're thinking to make some comments to maybe the coaches or the parents of how one comes up with these kinds of questions. You see, this is a very natural question. I just wanted to do it because I was curious. All these twos in the date for today. What happens if you put a bunch of twos together? In fact, math is sometimes about trial and error. And that's why I'm saying the first hint. Try some small cases. You see, because you don't need to be scared by a question like this. You can just try, does 2 work? Does 22 work? Try a bunch of these small cases. That's one way that will actually solve this problem. But you see, I'm sharing this kind of a thing because it shows how trial and error can also help to answer your curiosity. The best questions are those where you look at the question and you say, I'm actually kind of curious what the answer is. And when you're curious about something, try. In fact, one of the most important things when you do a problem is to go and try, get your hands dirty. But of course, that's not always the best because sometimes the answer is too big. So as you try, maybe you'll start to notice some patterns. And maybe those patterns might make you start to think about some more deep mathematics. For example, maybe there's a system behind what happens if I take a bunch of twos and put them together. That's the second hint. The second hint is that this number 222, you can write it as a product with a division inside it. 222 is 2 times 999 divided by 9. And of course, because 999 divided by 9 is 111, so it is true that that's 222. That's actually part of the recipe to a more systematic approach to this question. Now, another comment to the parents and coaches. I chose this question because there are actually a lot of ways to do it. There is the brute force way, which is what I suggested at the beginning. Then there's this other systematic way, which is also interesting. It involves number theory. And there will even be a third way, which involves some interesting coincidences about 7. But you see, what makes a good question is that there are all of these different ways that you could approach it. And so that brings us to maybe start playing with the question itself. In this problem, I want to show that if you don't know what to do, the best thing to do is just to get your hands dirty and to hope that you can find some kind of a pattern. So let's start. I need to know how many 2's I can put together to make something that's divisible by 7. What if there's just one of them? Well, of course, that doesn't work. I mean, maybe I would just say times 0. I get 0, and you subtract, and unfortunately, there's a remainder of 2. Well, let's try with 2 2's. If you divide by 7, let's do this again. Let's put the 0 here, subtract. I know most people would just have said put a 3 here, and 7 times 3 is 21. Whoops, what did I do? There was just a second. I apparently can't do division anymore. Just a second. It goes like this. 21, you subtract, and unfortunately, there's still a remainder of 1. Let's try it again with 3 2's. 2, 2, 2. Divide sign, a 7. All right, 7 times 0 is 0. Subtract, there's a 2, here's a 2. 7 times 3 is 21. Subtract, here's a 1, here's a 2. 7 times 1 is 7. Subtract, there's a 5. Still doesn't work. But I hope you saw something interesting happen while we did this. Look, inside the purple thing is a copy of the white thing. The white thing just so happens to be this part of the purple thing. And actually, the purple thing also appears in the green thing. It just appears right here. So this shows that if I want to do the problem this way, I can actually do it where I don't have to write a new problem each time. New problem meaning a new number of 2's. I could actually just continue. It's sort of like if you were dividing a number and you were going beyond the decimal point and you just add zeros. Here, let's just add 2's and see what happens. For that, let's try getting some more space. I'm going to have to write a bit smaller now. But so if I try to divide, okay, so 7, this time I'll save some space and I'll just not write the 0. 7 times 3 is 21. Subtract, there's a 1. Let's put a 2 here now. Put a 2, oops, I can't put a 2 up there. 7 times 1 is 7. Subtract, there's a 5. Let's stick a 2 here. 2. 7 times, the 7 times table. 7 times 7 is 49. Subtract, there's a 3. Here's another 2. 7 times 4 is 28. Is this ever going to finish? I hope so. So here's a 4. Oh, that's great, because 42 is a multiple of 7. I can put a 6 here, 42, bam, and I'm done. Actually, what I wrote here is a completely true statement. 2, 2, 2, 2, 2, 2 divided by 7 looks exactly like this, and it leaves that quotient on top. So the answer is that 6 2's is the fewest number of 2's, so that I can have a number that's a string of 2's and divisible by 7. And that wasn't so bad. But I'm showing that when you have a hard problem where you don't know how to start, just start. And if you just start, you start noticing a pattern that saves you work, and eventually you do this. But this question isn't just here so that we can spend 15 minutes doing brute force work. I hate brute force work. The interesting kind of math is the math for lazy people like me, who don't really want to do brute force, but want to see if there's something clever or something I can think about. Well, how about that other hint? There was another hint that said, if I have a bunch of 2's, well, for example, 2, 2, 2, that was equal to 2 times 999 divided by 9. Now, that's much more complicated looking than 2 times 1, 1, 1. But there's a reason. The reason is because this can be rewritten as 2 divided by 9 times 10 to the power 3 minus 1. Aha. So now there's a question of when is this divisible by 7? At first it looks like it's a fraction, so what does it mean for a fraction to be divisible by 7? But it's always a whole number. This is always a whole number because 9 divides into that, no matter what. When I say no matter what, I mean even if I have more 2's, you see that 3 there? If I had 15 2's, that 3 would just be a 15. And so if I'm looking for this whole thing to be a multiple of 7, since the 9 will just divide into there, and because 9 and 7 are what we call relatively prime, they don't have any prime numbers in common, prime factors in common, then the question just becomes, what power of 10 minus 1 is a multiple of 7? I just need 10 to the power something minus 1 divisible by 7. Now, this is moving us from some relatively brute force but straightforward arithmetic problem into a problem that involves number theory. Now, number theory is a very interesting subject. I don't have the time in this 15 minutes to teach the whole thing. Actually, that's why we made an entire course about number theory. But I'm just going to say a few things that if you have learned the course or if you are looking at some number theory, these are some ideas that will be really helpful. You see, what I'm really looking for here can be rewritten as, I would like to know when is 10 to the power n congruent to 1 mod 7. This kind of notation is something that you learn in number theory. Whenever you write a 3 equal signs, what that means is that both sides of this have the same remainder when you divide by 7. I actually skipped a step here because this is the more advanced explanation. The more advanced explanation would be to say, well, I need to know whether that is divisible by 7, so then that would need that the 10 to the n has a remainder of 1 when I divide by 7. That's what's here. But something else that's really powerful when you look at modulo another number is that you can actually simplify. You see, 10 to the power n is always going to have the same remainder when I divide by 7 as 3 to the power n. And that's because 10 and 3 have the same remainder when I divide by 7. This is one of the very useful facts in number theory. And so now, I just have to ask myself the question, oops, that's supposed to be a Q. Here's a question, that's supposed to be a Q. Sometimes my pen acts up. Let's see. Wow, it's really acting up today. Let's try this. Maybe it was my finger. The question is, when is 3 to the n congruent to 1 mod 7? So here, I will just try to figure this out by taking a bunch of powers of 3. The calculations here are now going to be a lot easier. Watch. I'll draw a table. Here's n. And what I'll write on the other side is 3 to the power n. I'll actually say mod 7. What I mean there is the remainder when I divide 3 to the power n by 7. You see, the key was, as soon as I get that power of 3 has remainder 1 when I divide by 7, I'm done. So let's try. If n is 1, 3 to the power 1 is 3, and the remainder when I divide by 7, it's still 3. If n is 2, 3 to the power 2 is 9, and 9 divided by 7 leaves a remainder of 2. If n is 3, I could calculate 3 cubed, but I'm lazy. If I already know that 3 squared has a remainder of 2 when I divide by 7, multiplying by another 3 will give me the same remainder as multiplying the 2 by the 3. So if I times 3, I get 6. And if you wanted to check, 3 cubed is 27, and 27 leaves a remainder of 6 when you divide by 7. Actually, what you're seeing here is you're seeing a flash preview of how powerful number theory is. We're saving a lot of work by doing very simple calculations. 3 to the power 4. Let's do the same thing. If I know that 3 cubed had a remainder of 6 when I divide by 7, multiplying by another 3 is the same as multiplying the 6 by 3. 6 times 3 is 18. But 18 has the same remainder when I divide by 7 as 4. Because 14 is a multiple of 7. Let's keep going. If I want to go one more, 4 times 3 is 12. 12 has the same remainder as 5. And here's 6. 5 times 3 is 15. Oh, that's the remainder of 1. And so I'm done. And so the answer is 6. This is very powerful. It sort of hurts me to not be able to use this time to explain to you how this works, but to actually talk through why each of those things work would be probably about a 1 to 2 hour lesson on number theory. But I hope that by seeing this, you now see how useful that is. You see, all of this fancy math was invented for a reason. It was to save work. And this is so much easier. Oh, but there's also one more way I wanted to talk about. The one more way was, the answer is 6. And 7. 7's an interesting number. What's 1/7 as a decimal? Maybe you've actually had to do this kind of problem before. And when you try to figure out what 1/7 is as a decimal, you start to divide, and you get 0.14285, and then it repeats. Actually, 1/7 is like the longest repeating pattern you have in a decimal for a while. As you're just dividing, 1/2, 1/3, 1/4, and so on, you suddenly get 1/7, and boom, it's really big. But something else that we teach in our algebra class, which you might also have learned before, is that once you see a repeating pattern like this can also be rewritten as 14285 divided by 999,999. And this is something that was one of the most interesting patterns that, from my opinion, that I saw when I was in middle school. I was like, wow, you can take repeating decimals and just do this. You just take the part that repeats and put it over as many nines. Seems like magic. And of course, it's not magic, it's math. And there's even a reason why. In a proper course, we actually do teach you why. But wait, look at this. From what I've just written down, it's now obvious that 999,999 is a multiple of 7. Because this fraction needs to be able to reduce down to 1/7. So just from what I wrote down here, this implies that 999,999 is a multiple of 7. Aha. Well, since 9 and 7 have no common factors, that actually tells me that 111,111 is still a multiple of 7. Because if I divide this by 9, it's not going to get rid of any 7s. Well, if that's true, this tells me that 222,222 is a multiple of 7. So actually, if you happen to remember that 1/7 was 0.142857, you know immediately that 6 is a possible answer. The question did say, what's the smallest number of 2's that you can put together? If you want to think a little bit more for a little challenge, you can actually show to yourself that if the answer was any shorter than 6, then 1/7 could be written with less than 6 things repeating. And it can't. So that's actually why the answer is 6. The answer happens to be just the length of the repeating sequence. And that's it. So that's the question that I wanted to bring for today. Actually, this question was inspired by the fact that, it's 2/22/2020 and it's 20 o'clock. And so the first thing that came to my mind was, I wonder if there's any interesting problem that involves lots of 2's. And what can you do with lots of 2's? Well, maybe I can try to see if they could be divisible by some really annoying number. And 7 is the most annoying number. And so that's how the question came about. But I wanted to share it with you because, as you can see, this actually got to touch a lot of very interesting principles. I unfortunately, in this short live stream, cannot go and explain why every single one of those principles is true. But my hope is that by doing this every week, you'll also get this tour that says, it would be interesting to learn some number theory. It'd be interesting to learn some algebra. And that's how they all fit together. This brings us to the second main portion of our weekly live stream, where I say a little bit about maybe things that might be happening, some interesting math news that maybe caught my eye over the last week. So one thing which we will not talk about is the MATHCOUNTS competition in the US, because the MATHCOUNTS competition is not over yet in the chapter level. There's actually one more weekend, so please don't discuss that yet. Instead, I'll say, I happened to notice that there was a headline that was flying all around the news in the last week, it was a very controversial title. It was something like, Why Americans Are Bad at Math. I actually find it a very offensive title, to be perfectly honest. And at first I thought, what kind of person wrote an article like this? And I looked, and it was the president of Barnard College. And I said, well, maybe then she knows what she's talking about. Let's see what this is. And it was very interesting. Let's ignore the headline. I find headlines to be just very sensational. At some point, if you yourself find yourself in the newspaper, you'll discover that somehow whoever wrote the headline was just trying to attract people to read the article anyway. But the content of the article was pretty interesting. What it showed was a study that some people had done. Actually, it was the author of the article. And the study was to present people with easy and hard problems, and to give them an actual cash reward if they solved the problems. And if they solved the hard problems, they got more money, bigger prize. And what they discovered was that people who were anxious about math would actually not try the hard problems. And they would just maybe try the easier problems, even though that had a lesser reward. And so this was the principle of the study was to say, actually, it's not really that people are bad at math. It's just that people are somehow anxious or lack confidence to try to attack hard problems. Something that was also pretty interesting was that part of the study also had some word problems. And apparently, actually even people who were anxious about math were willing to try the hard word problems. So apparently, because of the anxiety going away, people were then willing to try the hard questions and then possibly get the bigger reward. Now, when I read something like this, I actually always think, does this make sense? And I will say, actually, as I've run around the whole world trying to help talk to people about math, it actually does strike on something that is true, which is that everyone needs to have the confidence to solve hard problems. And actually, when I read that, here's another message for any of you who are watching who might be younger. A little bit of life advice that I want to share is that those hard problems are the ones that are worth it. In life, a lot of the hard things to do, the harder things to do, are the ones that will get a lot more for you in the end. So it's much better to gain the confidence to go and say, if I see something that I don't know how to do, it might have a huge reward, I'm going to try to figure it out. And that's also why the way that we ran this live stream was that I started with a hard question. And I wanted to let you see if you can think about it. I encourage you, whenever you go and learn mathematics, try to find a way where you don't just have someone tell you how to do the problem. Instead, find a tough challenge, fight with it, maybe get some hints along the way. And then someday, when you find those hard problems, you won't be scared to attack them either. These days, when I go and think about what I want to spend my time doing, I actually only want to work on the hard problems. They're the ones that are really worth it. And I wish you the best in your journey as well. With that, I'm going to roll into the third part of this weekly live stream, which is the random questions and answers that anyone might have chosen to ask. So right now, feel free to punch in, type into the YouTube comments, any questions that you might be curious about. This week, we'll take a lot of different types of questions, but I will say that as we move into future weeks, we're actually going to probably focus the topic areas of the questions into a rotation. But this week, it's still anything is up for asking. Let's see. What do we have here? Wow, we have lots of interesting questions. Here's one. How can you create hard, easy problems yourself? I like how this person used the phrase hard, easy, because that's really what you want. Don't work on easy problems. They're a waste of time. You don't learn anything from them. In fact, you just waste your time having to do the calculations out and write stuff down. Hard problems, if they're too hard, it's also not good, because if it's too hard, you'll waste a lot of time thinking about it, and maybe nobody will give you any hints, and you'll just not get anything. But hard, easy, that's interesting. How do you create them for yourself? Well, I'll say if you are able to go online and look for some of the old math competitions problems, I generally recommend going to find like the AMC 8 or AMC 10 or higher level questions and go and work on the ones that you know from experience are not immediate for you. It's not like you look at it and you know what to do, but rather the ones where you know that if you fight with it for 10-15 minutes, you generally get an idea. It's really nice that people who wrote these contests actually went through the effort to go and order them in difficulty. So because of that, you can actually go and choose the ones that are in the middle. Now, if you want to create hard, easy problems for yourself, I'm going to say that's actually very difficult. In fact, it's almost impossible. The only way that I create hard, easy problems is that I think about things that I'm curious about. Like, how many 2's do I need to get a multiple of 7? And I come up with lots of different questions, and most of them are too easy or too hard. But after coming up with lots of different ones, I finally find some that are just right in the middle. And then I use them for my teaching. But you see, I told you that story because that's not as practical for you. You probably aren't trying to teach someone, unless this was a question that was asked by parent or coach. If so, I just gave you the answer. But if you're a student, if you're trying to do this, the best is to go find someone else who's already done it, or you'll spend a lot of time. But for a parent or a coach, I will say, find things that you find intrinsically interesting, that you can be passionate about. Some of them are too easy. Some of them are too hard. Whenever you find one that's hard, easy, bam, that's perfect. Then share it with all of your students. More questions. What else can we get here? Okay. What do you recommend a beginner to start learning with? I love this kind of question because some people assume that because I'm the coach of the US Math Olympiad team that I only care about the top students. Nothing could be farther from the truth. I actually care the most about beginners because I think that this kind of thinking about math is something that everyone can do, and if you bring more beginners in, you'll just get more people to be smarter, and that's a better world. Now, for a beginner, what I would recommend is, first of all, make sure that you can do the school math. The school will teach you pre-algebra. It will teach you how to add fractions, multiply fractions, what a percent is. Make sure you know what that is. Make sure you have a good foundation that you can do those calculations. But the moment you have that, don't just rush ahead and try to, for example, find some like YouTube videos that will teach you all of 8th grade, 9th grade, 10th grade math faster. No. At that point, the best thing to do is to go and start thinking about some questions that will use those pre-algebra ideas in more interesting ways. You can do that either by doing the old problems which are online, or if you go and look for classes, you can. I'll give you the advice that when you look for classes, make sure the classes are not just teaching you a method that you copy. I will say we actually do run those, but there are many good resources in the world, and you should always just look with this eye of what's going to teach me as a beginner how to come up with my own solutions. And that will help you a lot. More questions. What do we have here? Oh, I see somebody asked, how do I take notes better? Oh, you're a very responsible person. If you want to take notes better, I would say the hardest thing to do is to decide how much to write. I actually always really enjoyed paying full attention to whoever was talking and just like enjoying every moment of it and asking questions whenever I had anything I was curious about. I do recommend that approach. Now, what that means is when you take notes, you have to actually decide what you're going to write down. So my advice is not to write down every word that you hear. Instead, you use bullet points. You say, oh, here's the general kind of question that we're about to do. Question. Here's the statement. And then it's like, okay, here's the first key idea of how to solve it. Quickly, scribble down first key idea. And then scribble down next key idea. You don't need to write down every single word that's said, because if you do that, you won't be able to concentrate on thinking as it's coming in. So my advice would be to write down that abbreviated batch of notes, and then afterwards, maybe to actually look at the notes again to see if you can piece them together and fill them out more. I will say there are other techniques though. Some people actually do like to write down everything. If you're that kind of person, you can write down everything, but make sure afterwards you also look at everything. Don't just assume that if you have written down everything, then you sort of know it. Because unfortunately, while writing it, you might not have been able to think as actively. That would be my advice for note-taking. Good luck. How do you know what to do every day? Do you have a schedule, or just think about what you need to do? So the way that I've operated has been very different at different phases of my life. I will say that when I was in school, I had a pretty clear idea of the kinds of things that I would need to do in the course of a typical week. I would know when big things are due. I would know when big projects are due. I would know that on the weekends, I wanted to make sure to spend time doing hard questions. Actually, I remember that when I was growing up, it was almost like every Saturday morning or something. I'll just reserve 3 hours to go and say, let's just think about some hard math questions, free of any other distractions. And actually, that was probably how I really learned math, because at that point, it wasn't just doing school homework problems. Nothing against school, but I'm just simply saying not doing routine homework problems. I was often thinking about Amy problems. But you see, by trying to compartmentalize the week and say, this period of time is really good for this thing, then you're able to get more done. Now, when you are in a situation like in school, this is definitely something you can do, because school is something where you do know there's going to be a unit, it's going to take a month, and at the end of the month, there's going to be a test. Like a lot of things are pretty predictable. And you even know that the math competitions are specific times of the year. So everything can be scheduled. And I would recommend that while your life is schedulable, I don't know if that's a word, but let's pretend it is. While it's schedulable, do schedule it. At some point later in my life became not schedulable. Nowadays, what I often do is I actually have all kinds of different opportunities to try to help more people get better at math or thinking. And I never know what's going to land. For example, I never know when the New York Times is going to have an article out that's about maybe something that I was working on. At that stage, you have to be able to adapt. And so in my later stage of life, the way I operate now is I, in my head, have an idea of priorities. The priorities are ranked in order of what is needing to be done, what needs to be done right now, and how soon it needs to be done. But at the same time, there's another priority. The other priority is, how important is it? How much impact will this have on the world, on my life, on the lives of those around me? And I sort of think about these two things all the time, of what's due soon and what will have huge impact. And I adjust accordingly. And then what this causes is it causes me to have to spend more time planning. And so actually when I'm walking around or moving from place to place, I actually have a bit of my brain always thinking, what should I do? How has my understanding of the world changed over the last 12 hours? Should I reprioritize something? Is something more urgent due now? And then that's how I operate today. But I wouldn't have been able to do that if I hadn't been more disciplined when I was younger. More questions. What do you do if your math class is too easy? So I want to give this advice. I think that it's very important to be respectful and to have a good relationship with your teachers and your classmates. Don't ever go and be this smart aleck person in the class who's like, I'm better than everyone else. It won't get you any friends, and it won't get you any help from people who can actually help you. Instead, what I recommend is this. In a math class which is too easy, you can always think about how you might explain things. This is what I always did. When I was listening to any class, whether math or something else, if I'm listening to someone else explain something to me, I always think, how might I have chosen to try to explain that? It's actually an art. Because when you do that, it's not only about how you'd explain it to someone else, it helps you understand it even better. And actually explaining something is one of the hardest things in the world. So that's how whenever somebody was teaching, whether I knew it already or didn't know it, I was actually really interested. Because I was like, how are you going to do this? It's sort of like how even if you already know how to play basketball, you might like to watch other people playing basketball, even though it's quote unquote, I'll say the analogy of easy in that sense is you're not the one trying to shoot the baskets, you're just watching someone else. But you can always try to learn something from that. And then the other thing that I always did was that in the time in the class, when there's time for us to work on our own, work on the problems, I would try to get that done quickly and correctly. And then I would go and try to help people around me in a respectful way that the teacher appreciated. This is good. It's actually very helpful. It gets you friends. It gets you respect from lots of people. And it's actually very enjoyable to do. And then what I'd always do is in the rest of the time, afterwards, say at home, I would actually use my free time to think about something harder. So it's actually not a bad situation to be in, to have that free time. So don't go and worry too much about how, it's not fair, life is not fair, I'm not getting a class that's hard enough for me. No, instead use those as opportunities to advance yourself in your own way. That free time is very powerful. More questions. Oh, here comes a question from someone called Jiang Michael. Why are some things in math undefined? Oh, that reminds me of something I was just talking about in my PhD level combinatorics class at Carnegie Mellon this week. You see, I was telling them a definition, and I made this joke, which is not really a joke, it's true. I said, in math, you're allowed to define anything you want. Definitions can't be wrong if you make up your own. But there's only one issue. If you make up a definition, it could be useless. You see, the value of a definition is not in whether or not the definition itself is true or false. It's defined. You decided to call this thing an oobleck. I don't know what an oobleck is. I just made that up right now. But no one can say it's wrong. You made it up. The question becomes if something's useful. And so that's why some things in math are undefined. For example, some people ask, like, what's 0 divided by 0? Maybe I'll write a little bit of something on this screen here. And let's see. That might be a bit easier. Just a second. So I just need to get into the... Now you see how I actually do all these live streams. Okay, here we go. Great. We're here. So, you might ask, what does it mean for the cursor not to work? That's a good question. Let's see. Actually, if you don't mind, one moment. Now you see even more things which are underneath. Well, you know what? Here's what I'll do. It's just because on my particular equipment today, it seems like my writing isn't that great. So I'm just going to continue and just explain, like why 0 over 0 is not defined. So if you wanted to have an answer for it, well, what would it be good for? The idea of division is it undoes multiplication. But now, if I have a particular number, that would be a problem. Because if 0 divided by 0 was 5, well, that would seem to make sense because 5 times 0 is 0, so that undoes the division. Division and multiplication are opposite. But I could just as well have made 0 divided by 0 be negative 2, because 0 times negative 2 is also 0. So this becomes a problem. And at that stage, there's just not a good definition that will help to keep everything else consistent. So a lot of the reasons why some things in math are not defined is because otherwise, if we define them to be something, the whole system of math would not be consistent. And the value of consistency is that whenever you're doing any calculation, you don't need to worry. I can always multiply and then divide and then multiply. And I'll get an answer that's supposed to make sense, as long as nowhere in the middle I went through something that was undefined. More questions. Does it matter if you know and understand formulas? Or can you just copy them? Well, it depends what you're trying to do. If you're trying to pass the quiz in your normal class, maybe that method works. But the place where that doesn't work is if you start to do things that are more complicated. Like the question we did in today's live stream. What formula would you use anyway? Actually, the formula that you'd use might be this idea that 0.142857, all repeating, was 142857 divided by 999999. But you see, that's not just something you copy. You actually need to understand what's underneath. That's actually what causes you to think of doing it in the first place. So what I mean is, if you just copy formulas, your ability to solve competition questions or exam questions will be limited to whatever questions match the formulas that you've remembered. But that's not enough. Number one, that's not efficient, because there's lots of different kinds of questions that you might see in the world, and it's not actually practical to memorize formulas for all of them. On the other hand, it's also not good because there are always new kinds of questions. And if you have a new kind of question and you just work by memorizing formulas, unfortunately, you also won't be able to come up with your own technique for solving it. And so that's why I recommend every formula also learn why it's true. And that's also why whenever I teach something, if I just say a formula, actually it hurts me because I'm like, well, I'd like to tell you why that's true. It's just that sometimes in the scope of a very short live stream, I can't quite do that. More questions. What do we have here? Ooh, this one's interesting. How do you apply math to arts? Now, I would say that there are lots of different kinds of arts out there. If you look at any of the Islamic architecture, actually it's extremely geometric. There's all of these different polygons and all of these different angles. It's amazing if you just stare at it to see the architecture of all of these intricate carvings. Maybe that's not your kind of art. Well, there's other kinds of art too. I'd call music also art. And it's pretty interesting that some people who are really interested in math end up really interested in music theory. You see, actually music is something that I didn't appreciate. I didn't appreciate how mathematical it was until I did a collaboration with Evie Claire. Actually, we have some YouTube video together that was from about last year where we were discussing about, music and math. And it's pretty interesting. The kinds of musical notes that sound good when they're both played at the same time turn out to be notes whose frequencies are, when you take the ratio of their frequencies, those are fractions. Those can be written as very close to fractions whose numerator and denominator are both very small numbers. For example, I'll give you an example. A sound wave is something that, does this. And your brain is very good at recognizing patterns. So for example, if there's a sound wave that's doing this, and there's another sound wave that perfectly matches it, but just does it twice as fast, your brain says, well, they seem to match. And that, by the way, is an octave. That's like a C and the next C when you're playing music. There are also other ratios which are very interesting, and those correspond to the chords that sound really nice, like pressing the 1 and 5. Actually, I don't really do music. I think that's like C and G, C, D, E, F. Yeah, C and G. That sounds very nice too. Once you make these kinds of realizations, it could also help you to figure out how to compose in more interesting ways. Actually, a lot of things that we do in the world have relations to math, even color. If you're thinking about color in the visual arts, you can often try to project the color onto a wheel. And then as you look at that, there are actually all sorts of tools that will find groups of colors that work well together by sort of spacing them across geometrically around these wheels. So all of these ways of thinking about math can help you to also, in the arts, create things that might be more pleasing. Another question. I'm Kyle. What do you think is hard or easy? Well, I don't exactly know how to interpret your question, so I'll interpret it in a way that I think might be interesting to answer. Things that I think are hard are things that I don't know how to do yet. Things that I think are easy are things that I already know how to do. And I'll tell you a joke. This is a fun joke about the mathematician, the engineer, and the physicist. This joke is that these three people were all sleeping in the same room, and at some point there was a fire in the wastebasket. And the engineer wakes up, notices the fire, and he does some kind of Rube Goldberg method of like a thing that rolls off of the table, and it causes a certain thing to remove all of the oxygen, and the fire goes out, and then the engineer goes to sleep. A little bit later, another fire breaks out in the same place. This time the physicist wakes up, and she uses her understandings of physics to find a way to, do something to cause a significant gust of wind to blow everything up. And then she goes back to bed. A little while later, the mathematician wakes up because there's a fire, again in the same place. The mathematician stares at it, and the mathematician figures out, I know how I would put that out, and then goes back to bed. So that's the joke. In some sense, mathematicians, or what I like to do, I like to find the things that are hard. As soon as I know how to do something, it classifies as easy. And then I would maybe not really be as interested in trying to solve it, unless it's important. And so the way I approach life is I actually try to find the things that are both hard and worth doing. And that's why I have this piece of my brain, which is always thinking, what sort of things would advance the well-being of people around me or people all around the world? And if they're hard and people haven't really done them before, then I'm really interested. So my hard and easy is based on, do I already know how to do it? Or will it be a challenge to try to figure it out? And if it's really worth doing, challenge, accept it. We'll take one last question for the night. How do you study for mock math counts? I'm in the team, and I want to help my friends win the middle schoolers. Well, I think I understand your question. You're basically saying, how would you try to study for this math counts if you're on the team? I will say one thing. I like how you mentioned there's a team. One of the best things that math counts and these kinds of competitions bring is it brings the ability for a bunch of people with pretty similar interests to come together and to learn from each other. You see, whether you win or not, that'll be one thing. But whether you actually had fun working together and learning together, that will last a long time. Practically speaking, go and find some questions to work on that are hard easy, not too easy for you, not too hard for you. as a random tip, whenever the group that I'm working with happens to find the sprint round questions pretty easy, we just do the sprint rounds backwards from question 30 to 29 to 28, just so that we can be doing those questions that are still a challenge. So get your group of people, work on challenges together. And as you do this, you'll not only figure out how to do math counts, you'll also make some pretty good friends. I actually am really happy about anything that brings lots of people together to think or talk about math. For example, I see that we have 264 people here on this live stream where we've been talking about math for the last 45 minutes. Anything that can create this sort of environment is ideal. Actually, I should also say, this is why we on the Daily Challenge also just recently launched our forum. So for any of you who happen to be in our courses already, I do want to mention that we actually have a forum for discussing the mathematics that's going on inside the courses or other mathematics. And inside this is another way for people to interact with each other and learn from each other. Whether from that source or from any other source, I wish you the best in finding a group of people to study with, because that builds not only understanding of math, but also a deep appreciation for both math, friendship, and maybe even how you can help the rest of the world and the rest of the society around you someday. One comment about next week's live stream. Next week, I'm actually going to be in Romania at this time. I'm still going to try to do this live stream, but what that means is that the style of it might look a little bit different because I'll be not with our entire studio here, which is able to run the live stream in this way. But I'll be there because I'm taking the United States national team to an international contest called the Romanian Masters of Mathematics. So maybe I'll say a few things about Romania too next week. See you next time.